We can discuss on the state function and path function, and not only that, thermodynamic process. These are very important topics of thermodynamics. Okay, so we can start with state function. So for explaining the state function or state variable, it is one of the property, function or property, any term we can use it, right? So here just imagine one example. State function, for explaining I took one example like this. This is my home, right? So from here I need to go to one supermarket. Okay, so here I need to go to that supermarket for buying something from them, right? So I started the journey from the home at 3 p.m. right, and reaches there in that supermarket at 4 p.m. So starting point it is home and finishing point it is the supermarket. So only we need to know about that. We started from here and reached there. And which way we are going, that's not a matter here. So here for buying something, I went there and the parents or the relatives only want to know whether I reached there in that supermarket or not. In which way I am going there, that's not a matter. So the path, it is not an important. The initial point and the final point is the only considering matter in this situation. So that type of the way it is said to be the state function or state property or state variable. That it is the function or a property which depends on the initial and final state of the system and not the path followed. So this is the, myself is the system though. So the system, that means myself, I started from here and reached there in the supermarket. So system start from here and reached there in the supermarket. System reached there. So initial and final state of the system only we are considering, not the path followed. That type of property we are calling the name, it is the state function or state variable. So the path function you can imagine now. Path function means it will be considering not only this initial and final state, that they will surely considering. Not only that, they will consider the which path the system followed. In which path the person, that means the system, going and reach there in that the supermarket. The path, it is important there. Not only the path, the initial and final state also. So that type of properties, it is said to be the path function. So the properties which depends on the path followed also, that means also here it is indicating that it also depends on initial and final states. That it is said to be the term path function or path variable. So examples also it is very important. Work and heat. Work and heat, they will depends the path. They will consider the path also, not only the initial and final state. But the temperature, pressure, volume, internal energy, enthalpy, entropy, Gibbs free energy, they are not depending on the path. They will consider in the initial and final states of the system. So that's why these all, the internal energy is a state function, enthalpy is a state function, entropy is a state function, Gibbs free energy is a state function. Okay, so all these terms you will study in this chapter again. When you say about this PVT, pressure, volume, temperature, these values, their values, it depends only on the state of the system and not on how it is reached there. The same way others also. So these all considered it as a state variables or state functions. Okay. Next term in thermodynamics, it is thermodynamic process. So, what is meant by the word thermodynamic process? The process by which a state change occurs in a system. With example, we can say that word thermodynamic process. For that, I took hot water in a beaker. So, you can imagine that it is a system. So, due to cooling process means any of the method you can adopt for cooling, keep for some time, or any ice cubes when you take and that hot water when you put it in another cold water. Likewise, any method you can adapt for cooling that hot water. So, we are doing something for cooling that hot water. So, after cooling process, what will be getting? Surely you will get cool water, right? So, what will be happening here? The system, due to the cooling process, it is changed to a cold water, right? So, what happens? The state, that means hot condition to the state, it is changed to cold condition. So, state change, it is happening there. State change due to the cooling process. In the case of a system happens. What happens to the system? From the hot to cold. That means state, it is changed due to one process. That process here, it is cooling. So, this process, it is said to be the word, it is thermodynamic process. In this situation, cooling is the thermodynamic process. In another example, another is the thermodynamic process. So, we can come to this definition. A process by which, the cooling process by which the hot condition to the cold condition, the state change occurs in a system. I think you understood now. Hot water changed to cold water due to the process of cooling. So, that process we can call the name is thermodynamic process. Because of that process, the state change occurs in the case of this system. Okay, this thermodynamic process, it is classified into 7 types. 7 types we can discuss now. First one, it is isothermal process. Isothermal. Iso, the word you know what's meaning, same. Thermal, temperature. So, isothermal means same temperature. Same temperature means there is no change in the temperature. If there is no change in the temperature, what will be the temperature change? It is considered as a 0. So, when any process occurs, here in this situation itself, hot water to cold water, any process, here in this situation, that one, it is not suitable because there is a temperature change, it is happening there. So, consider any of the process when we discussed above likewise. Okay, so when the processes, when it is occurs, when there is a temperature is constant, when the temperature is constant and due to that process occurs, there is no change in the temperature. That means delta T is equal to 0. That type of process we can call the name, it is isothermal. After the process, if there is no change in the temperature, that means temperature remains constant. The same temperature from the beginning to the end of the process. That type of process we can call the name, it is isothermal process, and that indicated by the letter, it is delta T, it is equal to 0. The next is isobaric. Iso, it is the same, baric, the term we are using for the pressure. Same pressure. That means beginning to end of the process, beginning time, what's the pressure? That same pressure at the end of also. That means there is no pressure change. That means the pressure change, it is equal to 0. Delta here, it indicates that pressure change. Beginning if it is P1 and end if it is P2. So that change, P2 minus P1, that change we are calling the name is delta P. Why it is delta P becomes 0? Because starting what it is the value, the same will be there in the end also. That type, that's why when we subtract that one, we will know if the beginning 10 is the pressure, at the end also we will get the 10. The same will be getting. So 10 minus 10, that is equal to 0. That's why we are telling that delta P is equal to 0. So that type of the constant pressure when it is maintaining over the process, it is said to be the delta P, it is equal to 0, and it is said to be the isobaric. Next type of process, it is isochoric. Isochoric means same volume. So starting beaker 30 ml it was there before starting the process. After the process also it is maintaining the volume, it is 30 ml itself. So there is no volume change. That means delta V it is equal to 0. Okay. So that type of process we are calling, the name is isochoric process. Next is the new term for you, that is adiabatic changes. Adiabatic process. So just consider one of the process now. This is the starting of the process and this is the ending of the process, the system. Starting process, and after the process this is the system. Okay. So process it is occurring here. Any of the process it is occurring here. Just imagine. So due to that process, if there is no heat is enters or leaves, the system is not receiving the heat and not given the heat to outside. Such a situation, if it's there, that process it is said to be the adiabatic process. In this process, there is no heat enters or leaves from the system. The overall process, it is continuing the same. There is at the end also, when you check how much amount it was there at the beginning, the same amount it will be, the heat, the temperature. So beginning time when you keep one thermometer here, so just imagine here 90 degree, here after the reaction, after the process also, when you check you will get the same thermometer reading. What's indication that the system is not received any of the heat and system is not given any heat to out. So that means the heat remains the same over the whole process. So that's why the heat change we are heat indicated by the term Q here. Q. So heat change we are indicating delta Q. The heat it is not having any change. That's why we are using the term delta Q is equal to 0. If there is no heat change, we know that's why temperature is also same. So temperature is also remaining same. That's why we can say that delta T is equal to 0. So for the adiabatic process, there is two conditions. It's there, delta Q is equal to 0 and delta T is equal to 0. Next is fifth one, that is cyclic process. Cycle, everyone knows that. Cycle means what it is. From here when you start, after some time we will reach there at the same point. That it is said to be the cycle. So what is meant by cyclic process? When it is occur in a cyclic manner, such a process we can call the name it is cyclic process. System from the beginning, just imagine this is the chemical reaction. This is happening in the system. So there is a lot of changes it is happening during this process, but it will be after the whole lot of changes also it will be reaches at the same point, that means initial state. So a lot of reactions, a lot of changes it is happening during this conversion, that means during that process, whatever the process we are doing, there is a lot of changes, but whatever the change, that's not a matter, it will be reaches to that same point. That type of reaction, that type of process it is said to be the cyclic process. Next is reversible process. Reversible. From that word itself you can imagine reversible means the process it should be reversed. How it is reversed? So just imagine one of the chemical reaction A plus B gives C plus D. So reversible means this is the way of representing. In both directions the reaction it will be followed. That means this is the starting A plus B. That means two chemical components we took for doing the chemical reactions. So there is some conditions it was there doing when the reaction begins. The temperature is 298 Kelvin or pressure is 1 atmosphere. Likewise conditions we took before starting this reaction. But when we altered the temperature or pressure, when you change any conditions, any properties like temperature from 298 to I changed to 378. Or a pressure I changed to 2 atmosphere. So the conditions or the properties it is changed. So what will be happen? There is a chance of reversing that reaction to the back. So there is such a situations it will be there. Such a type of reversing the reactions, reversing the processes. It is said to be the reversible process. So we can say that Irreversible process means when some properties of the system, when we changed, due to that the process it is reversed, that it is said to be the reversible process. Yes, just imagine this is one of the car. Just imagine this is the car. So here we given some force from here. So what will be happen? Surely it will be moving. Surely it will be moving. So this is the driving force we are giving. So in that situation, when we applying the opposing force, already we are giving some force, that means pushing from here. At that same time, we are trying to give force from here. The opposite way we are giving the force to this same car. So what will be happen? Which force it is more, on that side the car it will be moving. If there is a driving force, if it is more, so that way the car it is moving. Or if the opposing force, if it is more, so through that side the car it is moving. So when there is an equal way of force from both sides, what will be happen? There is no movement of the car. Just imagine the driving force and opposing force, both having some difference, that the pushing, that force it is having some difference, but that force is, it's not having the big difference, the small difference. If there is some person we are giving the force like this, or 10, the work, the force it is getting from that, and from the opposite side, just imagine the 12. So that means not a big difference between them, small difference between this driving force and opposing force. So that time what it is happening is that car it is moving in both directions. First it is moving there, afterwards it is moving back. Likewise it will be going there in both directions. When the movement it is very slowly also at that time. When there is a small difference between this opposing force and the driving force, that means like 10 and 12. Likewise, there is a movement of the car, it will be there. Car here it is, we considering it as a system. Right? So, there is a movement in both directions it will be. That movement will be very small also. Next one, it is irreversible process. That means we said about this example, no. The same thing you take it. Here, one thing, the driving force it is 10 itself. The opposing force you just imagine 20. So there is a large difference in that value. That means the force from the opposing side it is more. So the car will be moving that side only. So that means only one direction the car it will be moving. When there is a driving force and opposing force, both will be having the large difference in the value. So, only one direction, irreversible. There is no reversible process. Only one direction, the system it is moving. So, that type of process we can call the name is irreversible process. There is a large difference in that value. If there is a large difference in the value. Okay, so we can conclude that if the driving force, if it is more, that direction only the substance it is moving. If the opposing force it is more, that direction is substance it is moving. So surely what will be happen? There is no chance of reaching the equilibrium. Only one direction the car it is moving. But in the case of reversible process, we can say that if there is a small direction, small difference, what will be happen? That side and this side. Likewise, both directions the moment it will be there. So finally it will be reaching in a thermodynamic state. That means one stable state. That means equilibrium state. That means in an equal rate the car moving. Not in a one side it is more, that side opposite side it is more. Not like that. In a same rate it will be moving in both sides. So such a situation it is said to be the word thermodynamic equilibrium. So the equilibrium it will be attaining in the case of reversible process, but in the case of irreversible process there is no chance of attaining the equilibrium. This term equilibrium you will study in detail. One chapter it's there for you, that is the 7th chapter after this thermodynamics. Okay, the word you will get at that time very clearly. Okay, thank you.